Okay. So we know what a chord is. We know what an arc is. We know what a diameter is. Okay. So today we're going to talk about some theorems involving chords and arcs. What did I tell you at the beginning of this semester?
No more proofs.
Okay. So what do you think my answer is?
No more proofs.
Okay, so I want you to look at this cute little picture right here. In this cute little picture, if we have chords that are congruent in a circle, it has to be in the same circle. Okay, then we know their arcs are going to be congruent. Does that feel like it makes sense? I'm sorry, I didn't tell you what page this was. This is page 290. All right, I want you to draw with me circle C. Could you please draw this circle with me? Everyone's out to get me. At least it was my foot and not my chin. Okay, so I want to know the measure of arc AB. That's what we're on the hunt to find. Okay, so tell me something. What is true about the measure of arc AB? Ben?
It is congruent to the arc of BE.
Okay. And what? Okay, so arc AB, if we call it X, is the same as arc BE, which is the same as arc DE. What?
Like, if we're talking about how the arc BE is, could I say that it's congruent to arc BE?
Like this? Yep, we can write that. These three arcs are congruent because their corresponding chords are congruent. And that's what this theorem is saying. So if I want to know the measure of arc AB, what do we know about those three arcs? What do they need to add up to be? What did you say? Okay, if AD is 30 degrees, how much is left over? 330. So our three arcs need to add together to be 330 degrees. Which means each arc is 110 degrees. And do you mean when you say sides, the chords? Yeah. And I'm saying specifically chord because it has to be a chord. Okay. Yes. That's okay. That's okay. Yes, if the chords are congruent, the arcs are congruent. Okay. And it can go vice versa. Okay. So if you know something about the arc and they're the same measure, then you know the chords will be too. Okay, so it can go this way or it can go this way. Okay. All right, here we go. If a diameter is perpendicular to a chord, then the diameter bisects the chord and its arc. Well, let's digest that a little bit. So we have a diameter, right? And we have a chord. If we have a 90-degree angle between chord and diameter, then what's happening is our chord is being bisected. So those two little pieces are congruent. Okay. Also means these two chord arcs are congruent. So we're going to draw a picture, okay? We're going to draw a picture of circle C, where GE is the diameter, and we have a chord, DF, that is perpendicular. Okay, DF has a measure of 16 and GE has a measure of 10. I want to find length X. All right, what do you think? So we know that DF is how long? 16. So let's process this. DF is a chord that is perpendicular to our diameter. So what's true about D to here? It's going to be 8. So let's go ahead and mark that this guy right here, I'll put it in orange, is 8. We know that is 8. Do we know something else that would be helpful? Could we draw anything in? What can we draw? Okay, and if I draw this hypotenuse, do I know how long it is? Yes, you do.
Oh, it's a radius. Oh.
It's a radius. So it is 5. Why? It's not 5. It's not 5. I'm sorry. This is supposed to be, Miss Homan, that's a C, not a D.
Oh. Oh. I was about to say that.
I know. It wouldn't have made sense. My handwriting got a little crazy.
Wait.
Okay, so why can we do that? We know CE is 10. That's our radius. So we can draw as many radii as we want to, but only one actually helps us, right? Because if we draw this radius and we know it's 10, what do we have? We have a right triangle where we can use the Pythagorean theorem to get. Okay, some of you even know your Pythagorean triple, where you can see 8 and 10 and know that x is 6. We've done the Pythagorean theorem so much.
I mean, I just squared 8 and then it was 64. And then
Yep.
minus like 1.
Watching the games tonight?
Yes.
I really wish it wasn't so late that the second one started, but yeah, they do. Okay, so this theorem 10.8, it's just the reverse, okay? If we have a chord that's perpendicular and it's bisecting, then we know that's going to be the diameter. Okay, so these two go together. Okay, it's just the reverse. Okay, all right. Now this one is a fun one. If we have chords that are equidistant from the center, then they will be congruent. Okay, so let's talk about what that means in terms of like this picture right here. Okay, first of all, distance has to be measured with a 90-degree angle. So you notice how we have that happening here. Okay, so what this means is if GE and EF are the same with that 90-degree angle, because we're talking about distance, then our chords that looks bad, CD and AB are going to be the same, which then would affect our arcs as well, right? If those are the same. Okay, so it goes both ways. If we have two chords that are congruent, then their distance to the center is the same. Backwards, if the distance to the center is the same, then the chords are congruent. So let's draw a picture. Are we getting really good at drawing circles?
I catch him.
Only had like two of them were from the FC.
That packing? They should get 3 from each one.
No, I turned those in a long time ago. I did it. It was work on.
Like,
you
can't say no without a 100. No one gets a 100. I feel like
he's like, a 3 is proficient.
Yeah.
And that's like an 80%. And I'm like, my parents are yeah.
There's 4 questions.
Okay, so let's talk about some things that we know from this. Okay. If CT is 42, does that help us know another measure? And what would AC be? Also 42. Since these two chords are equidistant, we know that they're going to have the same measure. Okay. What else is something that we know from this picture? What about arc AC?
124.
Ooh, on 24, if CA and CT have the same measure, then their arcs are gonna have the same measure. Okay, so let's get Pac-Man's mouth there. What about arc AT? So if this is 124 and this is 124, okay, 112? Okay. Okay. Friday. I'm good with that being the end of our notes. Your homework is the student journal. So turn the page. And it's literally 8 problems. Can you handle that?
Put that like horrible type. That's just so easy.
Notes are good.
Your notes are like.
Oh, yeah.